What is my favourite number greater than 1,000,000? Why am I even asking that question? Because there are many people posting videos on YouTube to answer that same question. Why not join in? I am a little hesitant to offer a favourite number, but I must admit I do have a soft spot for 12,532,590,168. Let me first explain why I hesitate to put this one forward, and then why I have a soft spot for it. My hesitation is because I think favourite numbers ought to be based on the intrinsic property of the number itself, not on the notation that is used to express that number. Let me explain what I mean. Here is an example of an interesting number expressed in terms of plastic soldiers. What makes this interesting is the number of different ways that this group could be split up into smaller groups of equal size. For example, I could divide it in half with this half and that half of equal size. I could send each soldier out on their own as a single unit. I could divide it into pairs. I can't divide it into groups of 3 because there would be one left over. But if you looked at all the different ways, the different size groups that I could divide this number into, this is what you get. All these different possible sizes of group. What makes the number interesting is that that number that you can see now is the same as that number. Perfect, you might exclaim. And what is most important from my point is that this does not depend on how you express the number in any particular notation. I could describe it as 11100 in binary. Actually, that's not a bad way to describe this particular number, and the fact that it begins with a series of ones and then almost as many zeros is no coincidence. Or I could describe it as XXVIII in Roman numerals, and it doesn't matter how it's described. We could just use what we might call the tally system. One object representing each unit. But whatever notation, it's interesting because that is the same as that. Take this number. This is interesting in a different way. It uses every digit from 0 to 9 once and once only. But what makes it fascinating is that the first digit, 3, is divisible by 1. That's no big deal. But the first 2 digits, 38, are divisible by 2. The first 3 digits are divisible by 3. The first 4 digits divisible by 4, and so on, divisible by 5, 6, 7, 8, 9, the whole thing divisible by 10. This is interesting, but only when the number is expressed in the usual decimal notation. That, to me, makes it slightly less interesting than this number, which doesn't depend on the notation. And the reason I hesitate to bring my suggested favourite number forward is because it is a number which depends on the notation. But I do have a soft spot for it because it's, in a way, my number. I found this number, I discovered it about 20 years ago using pen and paper. No calculator, no computer. I searched for this kind of number and I was delighted to find it. So what's interesting about it? Well, the interest actually is not when it's expressed as it is here in base 10. The interest is when it's expressed in base 13. In base 10, we use 10 symbols. In base 13, we need 13 symbols. We use 0 to 9 as usual for 10 of them, but we have to throw in A representing 10, B representing 11, C representing 12. And we don't need to represent 13 with a special symbol because that in base 13 would be 1, 0. I'm not going to go any further into explaining different bases. What happens when you write this in base 13? It is 1, 2, 4, 9, 5, B, A, 8, 3, 7. Still doesn't look very interesting. But it becomes interesting when you multiply it by any number from 1 up to 10. I'm not going to multiply by 1. That is something you can do on your own. It's not difficult. Let's pick a different number. Let's multiply by 3 and see what we get. 3 times 7 is 21, but we have to think in base 13. 21, in base 13, it's 13 plus 8, so you would write it as 1, 8. So we write 8 and we carry 1. 3 times 3 is 9, plus the 1 that we've carried is 10, which is A. 3 times 8 is 24. That's 13 plus 11, or 1B. So we write B and carry 1. 2, 3 4s, 12, 14, that's 1, carry 1. 3 2s, 6, plus carry 1 is 7. 3 1s are 3. Okay. Do you notice anything interesting about the number we started with and what it is when you multiply by 3? I hope you can recognise that it's the same digits in the same order, but just starting at a different place. We start with 3, 7, then we go to 1, 2, 4, 9, 5, B, A, 8. If you multiplied by 2, 4, 5, 6, 7, 8, 9, 10, any multiple, you would end up with the same digits, but cycled round in a different order. You might wonder why I stop at 10, and that's because, well, there are only 10 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are only 10 possible ways of cycling that to get different answers. But I think that makes it interesting in base 13. And if you're curious, what happens if you multiply it by 11? Well, I'll let you do the maths yourself, but this is what you get. And that's a little clue as to how I actually went about finding this number. So there you have it, my favourite number, 12,532,590,168, or it's really only interesting in base 13, 12495BA837.